In the last video, we introduced the concept of lambda functions, which are simply functions that we define with a number of parameters. We include an expression, and we can then assign this anonymous function to a variable, which then stores this lambda function object. Now we can use lambda functions in conjunction with other functions that take in a function as an argument. And the first function we're going to look at is the filter function. Now the filter function is a built-in Python function. So if I type out filter and then put a set of parentheses and then take a look at the documentation that supports this, you can see that the filter function takes in a function and then it takes in an iterable. And you can see that we will then return an iterator yielding those items of iterable from which function is true. So what does this mean? Well, basically, this means the first parameter will take in a function. The second parameter will be an iterable, so a list, for example. And then when we run this, each item in the iterable will be sent into the function, and if it evaluates to true based on the expression, the result is returned. So let's see an example where we have a list, and we'll call this num_list, and inside this list, we'll store integers from 1 to 10. So this will be our iterable, and we're going to pass this as the second item in our filter function. Now the first parameter is a function, so I'm going to define a function, and my intention here is to filter out the even numbers from this list and return those even numbers as a new list. So I'm going to put lambda and then num, which is what I expect each of these items in the iterable to be passed into when we run the filter function. I'm then going to put a colon, and then I'm going to put in brackets num modulo 2 is equal to 0. So this is my expression, and therefore when we pass in num into this expression, it's either going to evaluate to true or it's going to evaluate to false. So when I run this code block, you can see that it relates to a lambda function with a single parameter called num. So what I can now do is use my filter function and pass in these two lines of code into the respective parameters. So if I put filter and then open a set of brackets, I can copy and paste my function code and place it as my first parameter. I can then put a comma, and the second parameter I can include my iterable, so I can simply type num_list. Now if we run this line of code, you'll see that we bring back a filter object with its respective location in memory, which is obviously very difficult for us to see the result, but as we've seen earlier in the course, in order to convert this into a list, we can pass this into the built-in list function. So if I wrap this in the list function, you can see that when I press return, we do indeed bring back 2, 4, 6, 8, and 10, which are the even numbers from our num_list. And we could then assign this to a variable called even_nums, and then we can then use this list in subsequent parts of our code. So hopefully not too tricky to understand, the filter function is a function that takes in two items. The first item will be a function, and this is where the lambda function is a good option. The second parameter is an iterable, and for each item in the iterable, it will be passed into the function and will be evaluated accordingly. If it evaluates to true, it will be filtered accordingly, and we can then pass this into the list object. Okay, so moving on to the map function. How does the map function work? Well, it's very similar to the filter function, but this time what the map function will do is take every item in the iterable and pass it into the function, where the function's expression performs some kind of action. So it won't evaluate to true or false and filter items, but it will perform some form of logic, and then it will be returned accordingly. So let's start with our iterable, and we'll define this as a list called odd_nums, and we'll set this equal to odd numbers from 1 through to 15. We can then create our function. So our function in this case is simply going to double the numbers within this list. So we're going to put lambda and then num. We can then put a colon, and then our expression will be num multiplied by 2. Now we have these two bits of information, we can pass them into the map function. So we can put map, and then the first parameter will be the function itself. So we can put lambda num times 2. And then we can put a comma, and the second parameter will be the iterable, so we can pass in odd underscore nums. Now when I run this code, you can see that we store a map object at the respective location in memory here. So in order to convert this into a readable list, we can pass this into the built-in list function. And when we run this, you can see that we obtain a new list which doubles every number from the odd underscore nums list. And if we wanted to, we could assign this to a variable for onward use. Now sometimes it's cleaner to compartmentalize your code, so what you may want to do in this instance is assign your list to a variable called odd underscore nums and assign your function to a variable called double to give it some form of meaning. I can then delete the lambda function inside the map function and I can replace this with the variable name double. And when we run this, we get the same result. And this to many is a lot easier to see because you can then see that the map function takes in two parameters, the first one being the function, which we can see is defined above, and the second one being the iterable, which we can also see is defined above. So in this video we've seen how we can pass in lambda functions into other built-in functions such as filter and map. Now we have already learned so many functions throughout the course so far, but we're about to embark on 6 different projects and I feel like there are a couple of functions that will be very useful for you to know before you start. So let me quickly walk through what these are. First of all, there is a Jupyter Notebook specific function that is very useful for making your output a lot cleaner. And this function is called clear_output. And the way we can use it is as follows. We first of all need to import it into our notebook. So we can put from ipython.display import clear_output. And once we've imported this function, we're then able to use it in our code. So let's now put this in a simple example. Let's say I print the string hello. When I run this code, we get hello printed to the screen, no surprises. If I then follow this line of code and print bye, we then get hello on one line and bye printed to the next line. I could then print an empty string, and on the fourth line I could print some space, then a pipe symbol, then some space, another pipe symbol, and some space. And if I print this, we get hello, bye, an empty string, and then the space and pipe symbol combination. Now, if I wanted to clear this specific output so that we did not see any of this on the screen, I'm able to call clear_output and then place some parentheses. So if I now run the code at this point, hello would have been printed to the screen, then bye, then an empty string, then our space and the pipe symbols, and then we execute the clear_output, which is why the output shows nothing. If I then follow this function with another print statement which prints coding to the screen, when I run this code cell in its entirety, we end up only printing coding to the screen because the output was cleared on the 5th line. Now if we were to set variables or define functions and then clear the output, it doesn't remove the definitions that you've previously stated, it simply just clears whatever is printed to the screen. So this can be very useful in keeping any output that you produce very neat and tidy, especially when using loops in your code. So keep this in mind for the upcoming projects. Another useful capability is to generate random selections, and we're able to do this by using the random library. So first of all, just like the clear_output function, we can import random, and we can then call functions from this library. And the first function I want to show you is the ability to generate a random integer between two numbers. So the way we can do this is by first of all calling upon the library, so we can put random. We can then place a dot, and then we're going to access a method known as randint. We can then open parentheses. Now at this point, if I were to open up the documentation, you can see that randint accepts 2 arguments, a and b. And you can see here in the docstring that this method would then return a random integer in the range a and b, including both endpoints. So if I were to put 0 as argument a, comma, and then 10 as argument b, When I run this code cell numerous times, you can see that we're generating a random integer between these two numbers. We don't get numbers less than 0 and we don't get numbers more than 10. So a nice way of being able to generate a random integer between two numbers. And just as an example, this could come in useful if you're trying to randomize what player goes first when playing a game. Now a second method from the random module that I'd like to introduce you to is known as choice. So if I put random.choice and then open up the documentation, you can see that the choice method accepts a sequence. And the docstring states that this method would then choose a random element from a non-empty sequence. And the sequence that we pass in as the argument is up to us. So let's say in parentheses, I were to pass in a list. And this list is going to contain 3 items: A, B, and C. So with A, B, and C now passed in as the sequence, when I run this code cell, you can see that the computer is randomly selecting either A, B, and C from the sequence. And if I were to put this in an example, let's say that we were playing the computer at a game of rock, paper, scissors, where the computer had to select either rock, paper, or scissors. This could be a good option in order to generate a random selection from a predefined sequence. So keep this in mind when working through the upcoming projects. These are the 3 pieces of functionality I wanted to introduce you to just before you dive into the upcoming projects. The first project we're going to tackle together is a number guessing game, so I'll see you inside the next video. Welcome to the number guessing game project. In this project, we'll create a number guessing game in which the computer will generate a random number. We will then get the player of the game to submit a guess. Now the guess needs to be compared to the number that the computer has generated randomly, and if a guess is too high, the player should get notified via a message. And if it's too low, the player should also be told so. Now if the player guesses correctly, the player should be congratulated. Now a player should only get 5 guesses in this game, otherwise it would be too easy. Once the guesses run out, the game is over. And the final feature we want to include in our game is to ask a player whether they want to play again. If they do, we replay the game. If they don't, we should break out of the game. Now you have learnt everything you need to know in order to produce code that will address this project. The chances are that if you go and try to code this up yourself now, we will produce different code. But this is absolutely fine. In fact, it's expected. There is no single right way to code this solution. There may be cleaner ways to code the solution, but that's not what the goal of this project is. We're looking to bring together the knowledge that we've learnt in order to construct a final game, and it's the problem-solving element that we want to focus on. If we break this project down into smaller problem statements, it becomes easier to digest and tackle. Give this project your best go without any help. When you feel like you can't go any further and you get stuck, then feel free to look at the solution video that I've put together in the next video. That being said, when you go through the solution video, try to pause it along the way and code it up yourself. Really try to understand what each part of the code is doing to get a full understanding as to how this application can be coded in its entirety. Good luck, and I'll see you in the solution video. Hi everyone, and welcome to the third project in which we're going to be developing a fitness app which shows us some body statistics. It will help tell us whether our weight is healthy, and it will also allow us to see how many calories we should be consuming in order to meet certain weight goals. Now, some of us may want to maintain our weight, some of us may want to lose weight, and some of us may want to put weight on. And this app will help us determine how many calories we should be consuming based on our own information. So Fitness Fan Limited have asked us to create a fitness app to help their customers. The application should allow a user to observe their BMI, which is known as the body mass index, and the respective rating. More on this shortly. They should be able to observe their BMR, which stands for their basal metabolic rate. They should be able to observe a daily calorie consumption expectation based on their BMR, and finally, they should be able to observe a daily calorie consumption expectation based on target weight goal. Now, there are likely to be a few things in this list of requirements that are confusing, but I've broken the application down into smaller tasks, and I'm going to walk you through where I've got the information in order to tackle this problem. Now, an interesting fact about myself that not many people know is that I'm actually a qualified personal trainer. I'm very much into my fitness and I love helping others achieve their goals. So this is something I use all the time in order to help customers work out whereabouts they should be sitting in terms of calorie consumption. Now, the first thing we're asked to do is create a function that can calculate a person's BMI, and the BMI formula is as follows. It's weight in kilograms divided by the height squared, where height is in meters. So if we pop across to the NHS website, you can see here that we're told that the body mass index is a measure that uses your height and weight to work out if your weight is healthy. And it's calculated by dividing an adult's weight in kilograms by their height in meters squared. The next thing we're asked to do is create a function that can output a person's BMI rating, and on the same NHS website, you can see that we have the BMI ranges. So if a BMI is below 18.5, the person would be classified as underweight. If they're between 18.5 and 24.9, they're considered healthy. Between 25 and 29.9, the person would be considered as overweight, and if you're above 30, you'd be considered in the obese range. So the app needs to be able to tell the user what rating they are classified as. We're then asked to create a function that can calculate a person's BMR, where BMR stands for basal metabolic rate. And in order to determine this, we're going to be using what is known as the Mifflin-Centaur equation. And I have picked this information up from the omnicalculator.com website, as you can see here. So what the BMR will actually provide is an estimate of the amount of calories that a person will burn whilst at rest. In other words, if you were not to do anything during the day, this is the amount of calories that your body will burn from all the chemical reactions that occur in everyone's body to maintain a living state. So with this information, based on our activity levels, we'll be able to estimate how many calories each of us consume on a daily basis. Now, the next function we're asked to create is using the Harris-Benedict equation, which is used to determine an individual's total daily energy expenditure. And the Harris-Benedict equation is a formula that uses the BMR, which is calculated in the prior function, and then applies an activity factor to determine the total daily energy expenditure. So if a person doesn't do any exercise, we need to multiply their BMR by 1.2 to give us an estimate of the amount of calories they'll burn in a day. If a user considers themselves as lightly active, in other words they do sports or exercise 1 to 3 days per week, we need to multiply their BMR by 1.375. If they're considered moderately active, i.e. exercise 3 to 5 days a week, we need to multiply their BMR by 1.55 to give us the calories that they would burn on a daily basis. Very active people will need to multiply by 1.725, and if someone is extra active, i.e. they have a physical job and they do very hard exercise 6 to 7 times a week, maybe twice a day, we need to multiply their BMR by 1.9. Now this will give us the amount of calories that a person will burn having considered their daily lives, i.e. their activity levels. And with this information, we can do one important thing. Depending on whether the user wants to lose weight, gain weight, or maintain weight, we have to either be below this number, above this number, or consume the same amount as this number in order to achieve the respective goal. Now the next thing we're asked to do is, depending on what the target weight that the user would like to achieve is, and the time frame they would like to achieve their goal in, we need to determine the amount of daily calories that they should consume. And this is very simple. People complicate the art of losing or gaining weight. Now if a person wants to lose weight, they should be in and maintain what is known as a calorie deficit. and a calorie deficit can be achieved in one of two ways. They can either eat fewer calories than what they burn, and the above functions provide us with the amount of calories that an individual is expected to burn on a daily basis, so they'd need to consume less than this number. Or another way of looking at it is that a person should burn more calories than what they eat, i.e. they should increase their activity levels in order to burn more calories. Now, on average, it takes about 3,500 calories worth of energy in order to burn 1 pound of fat. In other words, in order to lose 1 pound of fat, an individual would need to create a deficit of 3,500 calories. So let's break this down even further. If we want a client to lose 1 pound of fat in a week, they should be having a calorie deficit of around 500 calories a day. In other words, 3,500 divided by 7. And if we achieve this calorie deficit of 500, then the individual should be on a path to losing that 1 pound of fat in a week. Now we can take the same assumption the other way. If an individual wants to put on weight, then they should be in what is known as a calorie surplus, i.e. above the expected daily calories that they burn on a day in order to put weight on. So we'll need to think how we can construct this program in order to give the users this type of insight. The last two things we're asked to do is firstly create a function to see if the user wants to use the app again, and this is something that we're familiar with. And finally, we need to generate a body statistics report for individuals who use the app. So with all of the functions that we create above, we're going to need to construct a program that asks for input at specific times, calls functions at specific times, and then displays information on the screen to help users understand what they need to consume in order to achieve their target weight goal. So this application will not only test what you've learned in Python so far and reinforce that learning, but it's also going to provide a very useful application that you can use in your own time in order to help you achieve your body weight goals. Good luck in developing this program, and in the next video, I'll show you the way I went about creating this application step by step. In this fourth project, we're going to recreate the popular game Rock, Paper, Scissors. So you can see here that Games Limited want to add to their collection of online games. They would like you to produce a version of Rock, Paper, Scissors. Now hopefully you're all familiar with the game Rock, Paper, Scissors, and you can just get started with the project right now. You've learned all the skills you need in order to create a working game. But if you're not familiar with the game, let me just explain what the application should do. Firstly, we need to obtain a computer-generated selection. So the computer should either select rock, paper, or scissors. Secondly, we need to allow for a user of the game to also select rock, paper, or scissors. Once the computer and a user have selected either rock, paper, or scissors, we need to evaluate who wins each round. Now the rules are simple. If one person picks rock and the other person picks scissors, rock smashes scissors and therefore the person who picks rock will win that round. If one player picks paper and the other player picks rock, paper covers rock and therefore the person who picked paper would win that round. And finally, if one player picks scissors and the other player picks paper, scissors cuts paper and therefore the person who picked scissors would win that round. We also need the application to keep track of who's winning the game. Now if this is enough information for you, dive straight into the project and give it a go. If it's not enough and you want a little bit more guidance, the application can be broken down into the following tasks. Firstly, we need to create a function that obtains the user's input. We then need to create a function that generates a randomly selected choice for the computer. After both selections have been made, we need to determine the winner for each round and keep track of the score. Now once the round has been evaluated and we move on to the next round, we'd want to create a function that checks to see if a user wants to play the game again. They may not want to. And finally, like we've seen in all of our other projects, we need to produce a working application. So we need to produce a working game of rock, paper, scissors using a while loop and the functions that we create in the above tasks. Now you may be thinking, this seems like a simple project, and based on previous projects that you've done and learnt, I'm hoping this is something that you can do in its entirety with very little help. But the thing to remember here is that reinforced learning is key. You'll start to do things naturally without even thinking about it. Remember, there are so many different ways that you could achieve this program, but the goal here is to create a working game of rock, paper, scissors. Don't worry about how clean or efficient your code is for now, just utilize the features of Python to create something that works. With that being said, good luck in developing the Rock, Paper, Scissors game for Games Limited. Okay, so how did you get on in the Rock, Paper, Scissors project? Hopefully it went smoothly. If it didn't and you got stuck in any places, not to worry. Let's see if we can code it up together now and get a working solution. So the first thing we're going to do is import a useful function and a useful library that will help us in creating the game. So firstly, we're going to import the clear output function, which we know is from ipython.display, and this will just help us keep a clean program at the end when displaying the information to the user. So we can put from ipython.display import clear_output. Secondly, because we know we need the computer to generate a randomly selected item from either rock, paper, or scissors, we're going to import the random module. Okay, so with the imports now complete, let's dive straight into creating the game logic. Firstly, we're asked to create a function that obtains the user's input. So we know to create a function we need to put the keyword def, so we'll put def, and then we'll call this function get_user_selection, and then we'll put parentheses with a colon. Now the first thing I'm going to put within this function are the items that a user can select from. Now because we know they can only choose between rock, paper, or scissors, we're going to set a variable called choices, and inside this variable we're going to store a tuple, i.e. an immutable object with the items rock, paper, and scissors. I'm then going to set a variable called user_input and set this to an empty string. Now the reason I'm doing this is because I'm now going to create a while loop that just checks to see if the user input variable that we've set above is not in choices. So I'll put while user_input is not in choices, i.e. when it doesn't equal rock, paper, or scissors, then we want to keep asking the user for input. So I'll then put user_input as the variable and set this equal to the input function that asks the user to enter a choice. We'll then put in brackets rock, paper, scissors, and then we'll put a colon. Now after this input function, you may have noticed that in choices I've started each item with a capital letter. Now because we're comparing this user input to what is in choices, I'm therefore going to capitalize whatever the user puts in. Therefore if they put the whole word in capital letters or the whole word in lowercase, it will convert it to a capitalized version of the word and it should therefore equal choices. After this user_input definition, I'm going to put the keyword continue. Therefore, if a user was to put the word hello, we would then continue back up to the while loop. Now user input now contains hello, it's still not in choices, and therefore we're going to get asked for user input again. If the user input is rock, we then go back up to the while loop. User input is now in choices, so the not in choices evaluates to false, and therefore we're going to then return the user_input, which in this example would have been rock. So we've now defined a function that can obtain a user's input. Okay, so moving on to the second task. We're asked to create a function that generates a randomly selected choice for the computer. So once again, we're going to start by defining a function, so we'll put def, and the name I'll provide this function is computer_generated_selection. I can then put parentheses and a colon. In a similar way to what I did in the first example, I'm first of all going to set a variable called choices, and then I'm going to create a list of items that the computer can select from, so we know this is going to be rock, paper, and scissors. And after this line, I'm going to create a variable called computer_selection, which will just store the computer selection, and I'm going to set this equal to a call from the random library, and I'm going to call upon the method known as choice. So I'm going to put random.choice, and inside the parentheses, I'm going to pass in what items we want the choice to be made from, and in this example, we know we want to pass in the variable choices. And if you needed help to understand what the choice method would do, as a reminder, you can press Shift and Tab, and it will provide you some documentation. So here you can see that the method choice is asking for one parameter called sequence. And it tells us that this method will choose a random element from a non-empty sequence. Well, we have a sequence defined above called choices, which is simply a list. We can see that it's non-empty because it's populated, and therefore we'll get a choice from one of these three items. The final thing we need to do is return the computer's selection, so we need to return the variable computer_selection. Okay, so that's the second task complete, but let's just test to see if the computer-generated selection function is working as we expect. So let's call upon it to see what we get back. You can see that when I call upon computer-generated selection and then press return, we get paper returned. And if I go back up and run the function again, we get scissors returned. If I run it again, we get scissors once again. A fourth time, we get paper. Let's run it until we get rock. There you go, on the next time we run it, we get rock. So you can see that the computer is generating a randomly selected item from the list of choices. Okay, so moving on to the third task. We're asked to determine a winner for each round and keep track of the score. So in order to do this, I'm going to create a function that deals with both the conditional statement, so to determine who the winner is, and also keeping track of the score. So firstly, I'm going to define a function called determine_winner. And inside this function, I'm going to want to pass in two parameters. So this function will always expect two pieces of information. Can you guess what this is? Well, my thinking is that because we need to compare the player choice and the computer choice together, I'm going to want to pass in these two bits of information into the function. So I'm going to create a parameter called player_choice, and I'm also going to create a parameter called computer_choice. These will be the only parameters that I include, and I'm going to therefore put a colon after this function header. Now we know we also need to keep track of the score, and we haven't seen this in an example yet, so I'm going to implement this in a slightly different way. My expectation is that when I get to the very last step and produce a working game, I'm going to create a variable called player_score, and I'm going to set that equal to 0 to begin with. I'm also going to create a variable called computer_score, which can store the amount of points the computer gets. But in order to access these two variables that I'm going to define outside of the function, and bearing in mind I want to change these variables, I'm going to precede these two variables with the keyword global. And we saw the keyword global when we discussed scope. So I'm going to put global and then player_score, and then I'm going to put global computer_score. Now whenever I reference or change the values that are stored in these variables, it will change what is stored in the global variable. In other words, a variable that can be accessed anywhere in your code. Okay, so we can now move on to determining the winner of each round. And the way I'm going to do this is by simply putting in place some conditional statements that checks to see what's stored in player choice versus what's stored in computer choice, and then we will print a message to the screen that tells the user who won that round, and we also then need to change the value that's stored in either player_score or computer_score in order to update the scores accordingly. Now the first thing I'm going to do is firstly see if player underscore choice is equal to computer underscore choice. Now if player underscore choice is the same as computer underscore choice, we know that it's a draw. They've both selected the same item. So we can therefore print both players selected curly braces, we can then put a full stop, and then we can put it's a draw. We'll then use the format method and we can pass in either player underscore choice or computer underscore choice. So let's just pass in player underscore choice. Now this will actually cover 3 eventualities. For example, if player choice and computer choice both are rock, then it's a draw. If they're both scissors, then it's a draw. And if it's paper, then it's a draw. So there are 3 combinations here that will always result in a draw. So it's good to put this line of code first so you don't have to write them out individually later on. So with the event of a draw now covered, we can then put our second conditional statement. So we'll put elif player underscore choice is equal to rock. Now notice here that rock is with a capital R, and that's because we actually capitalized the word when we created the get user selection function. Now if the player underscore choice is equal to rock, well the computer choice could be one of 2. It can be either scissors or paper. We've already dealt with the situation where the computer choice would be rock in the statement above. So we need to have a nested if statement. So after rock we can put a colon, and then we can put if computer underscore choice is equal to scissors, and then we can put a colon. So at this point we know that computer choice would be scissors and player choice would be rock. Well, rock smashes scissors, and therefore the person who picked rock would win. So because the players picked rock, we can print rock smashes scissors, you win. And then after this print statement, we want to change the value that's stored in the variable called player underscore score, which we know we're going to define later. So we'll put player underscore score, and then we're going to plus equals 1. Now inside this nested if statement, we also need to put an else clause. And the else clause will capture the event where the computer underscore choice is equal to paper. So we can put else, then a colon, and we'll then put print paper covers rock, because the computer choice is paper and the player choice is rock, and then we have to put you lose, because the player would lose in this instance. And at this point, we'd want to update the computer score variable and increment it by 1. We've then finished this conditional statement, so we can go back out to the outer if statement and then cover the other possible scenarios. So we'll put elif player underscore choice is equal to paper, we'll then put a colon, we'll then create a nested if statement, and we'll put if computer underscore choice is equal to rock. In this event, paper covers rock, so we can print paper covers rock, you win. After this, because the player wins, we'll want to increase the player's score by 1, so we'll put player underscore score plus equals 1. Now if the computer choice was actually scissors, we can put else and then print scissors cuts paper, you lose. And then we need to increment what's stored in the computer underscore score variable by 1. And finally, the last possible outcome we could have is where player underscore choice is equal to scissors. Now if player choice is scissors, then we need a nested if statement to check what the computer's picked. So we can put if computer underscore choice equals paper, then we can print scissors cuts paper, you win, and then increment player score by 1. We can then put an else statement where it captures where computer choice is rock. We can then put rock smashes scissors, you lose. And then we can increment what's stored in the computer underscore score by 1. Now at this point, the function is complete. But we can't call upon this function yet because there are some variables inside this function that we haven't created. For example, player underscore score and computer underscore score. So we'll pause on this function for now and see if it's working when we get to the end. Okay, so moving on to the fourth task, we need to create a function that checks to see if the user wants to play the game again. And we've seen this before, so we can quickly go through this with hopefully very little issues. So we'll create a function called play_again, and then we're going to set a variable called replay and have this set equal to the function input with the message, would you like to play again? With some guidance that we want to either receive a Y or an N, so we'll put brackets Y/N and then a colon. We then need to check what they've put in, so we'll go if replay.lower, so we'll convert whatever they put in to a lowercase letter, and then a set of parentheses is equal to the lowercase y, then we want to return true, because the user has stipulated that they do want to play again. If they haven't put a Y, we'll then put else and we'll return false. Now this could be implemented better because if you think about the risks that could arise here, if a user put nothing or a Z or an N or a P, whatever the value they put, it's going to return false. But for now, because we're just trying to get a game that works and we have provided them some guidance as to what we want to see, we'll just put else and then we'll return false. And this function should work accordingly. Okay, so we're now at the point where we need to create a working game using the functions that we've created above. So we just need to make sure that we're setting variables and calling the functions in the correct order in order to make this game function. Now you may recall that earlier I mentioned that when we created the determine_winner function that I wanted to set two variables in the global scope, outside of the function and also outside of the while loop. So that's the first thing I'm going to do. The two variables that I created were called player_score, so I'll put player_score and set this equal to a score of 0 to begin with. And I'll also do the same for the computer's score, so I'll put computer_score and set this to an initial value of 0. I will then create the while loop. So I'm going to put while true and then a colon. So if you think about this, the only way that we can break out of this loop, considering that true is always equal to true, is if we break out of the while loop with the break statement. So to start with, I just want to welcome the player to the game. So I'm going to print a message that says, welcome to the rock, paper, scissors arena. I'm then going to, straight after this welcome message, print out the current score. So I'm going to print the current score is with a colon, and then on a new line I'm going to print player with curly braces. Then I'm going to put the pipe symbol. I'm then going to put another set of curly braces, and then I'm going to put computer. And this reads very similar to how it would if you were watching a sport event. I'm then going to use the format method, and inside the brackets, the first curly braces are going to contain what is stored in player_score variable. I can then put a comma, and the second set of braces are going to be inputted with what's stored in the computer_score variable. Okay, so at this point, we're just printing some statements to the screen. Now inside of our determine_winner function, we've included two parameters. So we're expected to get a player choice and a computer choice. So the first thing I'm going to do is actually get a variable which stores a value for these selections. So I'll start by creating a variable called player_choice, and I'm going to set this equal to a call on the getUserSelection. So when the while loop gets down to this line of code, the user is going to be asked for their selection. And when they're put in a valid selection, it will get stored in a variable called player_choice. Great. So now let's do the same for the computer choice. I'm going to create a variable called computer_choice, and I'm going to set this equal to a call on the computer_generated_selection function. So this will therefore store a randomly selected item from rock, paper or scissors and store it inside the computer_choice variable. Now at this point, I've got two pieces of information And I've got some print statements that are displaying some information to the screen. But I'm actually going to clear what's stored on the screen by using the clear_output function, which we know is Jupyter specific, just to keep it clean. And after it's been cleared, I want to print a statement to the screen, which tells the user what they've chosen versus what the computer chose. So I'm going to print you chose and then curly braces. I'll then put a comma. I'll then put computer chose and then curly braces. And then I can use the format method and place player_choice in the first set of braces, and then I'll put computer_choice in the second. Now at this point, all we've done is tell the user what they've selected and also what the computer has selected. But we haven't actually determined who has won the round. So we need to call upon our determine_winner function. And we know that this function takes in two arguments. One that relates to player choice and one that relates to computer_choice. Now we've called them the same thing here, so we can actually pass in our variables called player_choice as the first argument, and we'll pass in computer_choice as the second. This function will then be run, and we're going to compare the two values based on our conditional statements that we had written above. Now after it's determined the winner, we need to obviously display who has won and what the score is. So we can print to the screen the current score is, and then we can put the same line of code that we put above. Now theoretically we could have put this in a function so we're not repeating ourselves, but for the purposes of this example, let's just copy and paste the code again. Now the determine_winner function actually updates the score as well. So where we're calling and printing the player score and computer score for a second time in this while loop, we would have expected the winner's score to be updated by 1. And at this point, the round is over. We've already compared the values, we've already seen who's won, so we need to check to see if the user wants to play again. So what we can do is put if not play_again. And the only way that this will evaluate to true is if a user doesn't want to play again, because if they don't want to play again, we'll return false. The opposite of false is true, and therefore, when a user doesn't want to play again, we want to clear the output, so we'll call upon the clear_output function, and then we will print hope to see you soon. After this line, we're going to break out of the while loop, because they don't want to play again. Now, if the user does want to play again, they'll put y. Y returns true in the play_again function. The opposite of true is false, and therefore the if statement's code block will not be executed, and therefore we don't break out of this loop. But what we do want to do after they've decided whether they want to play again is clear_output, because the first thing that's going to happen when we go back up to the top of the while loop is we print out welcome to the rock paper scissors arena, the current score is, and it will then display the current score after the first round has been played. Okay, so we're now at the point where we can test our game. Let's see if the game functions and operates as we would expect. And the way we're going to do this is by going up to kernel, and then we're going to click on restart and run all. This will run all the cells that we've written so far, and we'll see how the while loop then performs. Okay, so you can see that when we get down to the while loop, we're presented with the message, welcome to the rock, paper, scissors arena. The current score is 0-0. Enter a choice, rock, paper, or scissors. So let's play the computer at a game, and we'll say that the first person to 3 wins. So I'm going to start by entering rock. Yes, rock smashes scissors, you win. The current score is player 1, computer 0. So it's working as we expect. The player did win, and hence the player's score has incremented by 1, and we're then asked if we want to play again. Let's put a capital Y. Great, so welcome to the rock, paper, scissors arena. The current score is 1-0. Enter a choice. Okay, this time I'm going to go with paper. Ooh, the computer also selected paper. It's a draw. Would you like to play again? Yes. This time, let's go with scissors. Rock smashes scissors. The computer chose rock, therefore the player loses. The current score is 1-1. Would you like to play again? Yes. This time I'm going to go rock. It seemed to be lucky the first time. They also selected rock. Let's go rock again. The computer chose paper. We lose. The current score is player 1, computer 2. Would you like to play again? Yes. Let's go with scissors. The computer went paper. It's 2-2. First one to 3 wins. Would you like to play again? Yes. Let's go with paper. How lucky. Computer chose rock. Paper covers rock. You win. The current score is player 3, computer 2. Great stuff. Would you like to play again? Let's put N because we don't want to go any further. And then we're presented with the message, hope to see you soon. Great. So we've managed to create a very easy rock, paper, scissors game, which is actually quite engaging with very few functions and a very small while loop. But hopefully you're now starting to get to grips with how we can present information to the screen, how we can create functions and call upon them, how we can store information in variables, and all the other features that we've learned throughout the course so far. All of these mini projects are a great way to try to solidify the knowledge that you're picking up throughout the course. If there's any part of this project that you didn't understand, please make sure you get in touch because it's so important that you understand the language first and foremost. We will make sure we get your understanding back on track so that you're not lost in subsequent parts of the course. I hope you enjoyed that project. See you in the next one.